welcome back to our channel Imaginary Engineering. This is Kirti. In this video, we are going to see the microservices. First, we will see the basic difference between the monolithic and microservices architecture. Then we will see the centralized configuration using the Spring Cloud config server. Then we will see the service discovery naming server using the Eureka naming server. Load balancing, API gateway. We'll cover all this point in this video, so watch this video till the end. And if you are new on my channel, then don't forget to like, share and subscribe to Imaginary Engineering. So in this monolithic architecture, all the components of an application are tightly coupled and run as a single unit. Oppositely, in microservices architecture, in microservices architecture, split an application into the smaller independent services. Each services focus on the specific functionality. It provides the flexibility to choose the best framework and language for each microservices. For example, microservice A using the language Python, microservice B using the language C++, Java, or any other language. Similarly, in microservice A using the database MongoDB, microservice B using the database MySQL or any other database. So it provides a flexibility to choose the best framework. So then second one is a efficiency. Suppose in our application we need to increase the capacity. In monolithic architecture, we need to scale entirely application because we cannot it is a tightly coupled and we cannot scale only the one part of the application. But in microservices, we can scale only the service that need it. So it will reduce the cost. Then next is a fault tolerance. If the one microservices fail, then it does not affect the other microservices. Other microservices will continue to run as it is. So this is the basic introduction of the microservices architecture. Then next we will see the centralized configuration using the Spring Cloud config server. First we will see the Spring Cloud config server. So first question is, why do we need the centralized configuration? When we have the monolithic architecture, we have the one application and one configuration file. So it will be easy to manage that one configuration file. But in case of the microservices, we have the thousands of microservices, multiple services. Then we have the multiple environment like prod, stage, QA. We have the multiple environment, and each one has the separate configuration file. So to manage all these files, configuration files, it will be difficult. So how do we do that? So for that, Spring Boot provides the implementation of the Spring Cloud Config Server. So we can manage store all these configurations in one place. So what we'll do, we'll create a Git repo locally and store all our configuration. Then we'll create a Spring Cloud config server, connect that server to our Git repo, and all other microservices then can fetch the config from the Spring Cloud config server. First I will create this product microservice. So let's start. Let's go to the Spring Initializer. For the project, I choose the Maven language Java. Spring Boot version, I will choose the 3.3.7. Don't choose the snapshot version because it's under development. Project group, let me change the name. Microservices artifact. This is basically the project name. Product service. Then yeah, all the things looks fine. Then packaging jar, Java version 21 I choose. Then dependency. First I will add the Spring Web dependency. Then I will add the DevTool dependency. This DevTool dependency, whenever we make the changes, our server will reload. Actuator. This actuator to monitor and manage the application. Then I will add the config client. this config client or client that connect the server Spring Cloud config server to fetch the application configuration. So we are ready. So click on the generate. It will generate the zip file. I will open this in my IntelliJ IDE. If you are using any other IDE, go ahead. It doesn't matter what IDE you are using. I will open this in my IntelliJ IDE. Here I have opened this product service. If I go to this form.xml, here you can see the dependencies that we have added. Actuator, starter page, then we have the Spring Cloud starter config. All the dependencies you can see here. In SRC folder, we have the two folders, main and test. If I go to the main, in Java folder, and then we have the resource you can see this application.properties file to configure the proper application. Then we have the Java folder. Here we have this our application main file, annotation, Spring Boot application. First I will go to this application properties and add the port server.port. I want to run this application on port 8000. Then I will create a package. Let's create a new package entity. Inside this entity package, I will create a new class, new Java class inside this entity. Call it a product. Inside this class, I want a variable product name, string name, and then variable product price. Then I will add another variable, port number. I want to show you. So port number I will add as a variable. Then we will generate the constructor, default constructor and parameterized constructor. This one is our default constructor, and then I will add the parameterized constructor also for the name, price, and click on OK. Then I will add the getter and setter method. It's generate getter and setter method for the name, price, and port. Click on OK. Here we go. Our product class is ready. Now I will add the another package. Click on the new, go to the package, add a package, product controller. Product controller. Inside this package, I will create a class. Go to the file. Inside this product controller, I will create a class. Product controller. Add an operation. Request controller. Add an operation request mapping and provide a path /product. So our URL start with the /product. Then let's define the get method, get mapping annotation added, and add a method, return this not string. I will return the product object. I call it get product details. Yeah. And it will return new product object. And what I will do, I will add a properties in our application.properties. I will add a two properties, laptop dot name equal to HP and laptop dot price equal to, let's say, 50,000. Okay, now we have this property saved in our application.properties file. I want to access that properties. So what I will do for that, I will create a one config folder. create a config package, config. Inside that config, I will create a Java file. Let's say app config, app config. I will add a annotation component. Then I will add a annotation configuration properties and our configuration prefix. I will provide our prefix is laptop. If I show our property name start with the laptop, so prefix here I will add the laptop, and we have the two properties that we want to access, which are the name and price. Name, and another one is a price. And then I will add the getter and setter getter and setter method for the name and price for the both. Click on OK. Now we have added getter and setter method. This is our configuration properties config file. Basically this one extract fetch the values from the application properties file for this name and price variable. Now next we go to our product controller. Here we add a app config variable, app config. We need app config. This is required. This app config have this get name method. It will return the name value, and then we have the get price. It will return the price value. Then next we need to add the port. Also for the port we have the variable environment variable, which is import from this co.env.environment. I will create a environment variable. Environment variable. Add annotation auto add. This environment variable have the property get property local dot server dot port. It will return the port number. We will store it in one variable or equal to yes capital, and then I will pass this port as a parameter. There we go. So we have the product and get product details. Now I will go to this product service and run our this application. Let's see. Here we get the error. It say no Spring config import property has been defined. So basically in dependency, if you remember, we have added the config client. So it's looking for the Spring config import property in application properties file. To fetch the config from the config server, this property we have to say. But currently we don't have the configure any config server. So simply what I will do, I will copy this and paste it here. We can disable this option, or we can just disable this config of cloud import enable false. But I will add this config file config property spring.config.import. This one is optional, and config server, which we haven't configured, but our config server, when we configure, it will be on port http localhost colon slash localhost colon port 880. So I will configure this server on port 880, and this one is optional right now. Let me rerun again. Yes, our application is running on port 8000 here. So let's go to the Postman and we'll check. I will create a new collection. Create a blank collection. Let's name it microservices, add a request, HTTP 8000 and slash product. Okay, click on the send. Here we get the result name HP, price 50,000 and port currently running on our application is running on port 8000. If you remember that price we have given that property name and price HP and 5000. That property we have set in our application.properties file. So next what we will do, if you remember, we have this flow. I have created these product microservices. Then we will create this local Git repo. Then we will configure the server and we will connect our server to the Git repo. First, I will create the config Git repo in this macro. Right click new. I will say directory Git config or we say Git repo. Then inside I will go to the terminal cd git repo, initialize the git folder git init. Now we'll create a file inside this folder. So let's create a file. Our application name is product dash service. Make sure that our this file name and our application name must be matched. Here my application name is product service, so I will create a file, new file, product dash service dot properties, and so this is our product service properties file. Git add dash, then I will add a comment git commit. I will add a git yum, let's say initial push, enter. If I show git branch, our current branch is master, we are on a master branch. So this is our local repo where we store our configuration file. Now what we want in our application.properties, we have this, right? We have this property set. I will copy this, come to this properties file. I will paste it here. Now our laptop name is HP. Now I want it Dell. Price is 50,000. I will make it 60,000. I want to fetch the configuration from this properties file. Okay. So this is our local repo is ready. Server. We'll come to the Spring initializer. I don't need this. Let's remove. Then here, product service, rename it to Spring Cloud Config Server. Packaging jar Java 21. Then add a dependency config server. Add a dependency central management for the configuration. Then I will click on the generate. It will generate a zip file. I will open it in our ID. We have our Spring Cloud config server. I will go to this src resources application.properties file. We will set the configuration here. I will add a port number server.port equal to 8080. Then I will provide a path for our Git repo. So add a spring.cloud dot config dot server dot git dot URI equal to this git repo path. I will copy the this path, absolute path, and paste it here. Since we are using on Windows, let me replace this slash the forward slash, and here we are using the local repo, so I will add the file colon triple slash. Now I have added this git URI, and also we have to do the one thing, go to this Spring config server application and add on notation enable. Here you see we can't see these suggestions. Let me add this Spring Cloud config server to our main project. So go to this Microservices Spring Cloud config server tools. Click on the OK. Here we have added this Spring Cloud config server. Now we can see the suggestions. Enable config server. Click on it. Now let me run this Spring Cloud config server. And if you remember in our product service properties file, if I show you this resource and this is our product service properties file, we have set this property spring.config.import. This basically import the configuration from the config server, and our config server which is running on the localhost port 880, that and our config server connect to the git repo, and we have this configuration. So basically we will fetch the configuration from this product service. So this is running. Tomcat is starting on port 880. Why is it on 880? I have given the port number right. Product service. If I go to the src main java application.properties server.port, let me rerun this. Oh, spelling mistake here. Spelling mistake. Server.port 880. Let me rerun this. Now Tomcat has started on port 880. So let's go to our Postman and check. Click on send. Now here you can see name is Dale, price is 60,000. We are getting these values from the git repo config file. If I show you here, if I go in our git repo, we have the laptop name Dale and price 60,000. Means we are fetching the configuration from this git repo. Now this microservices can have the multiple environment QA, dev, prod, how we can, and each environment have the separate configuration file. So let's create a config file for the, I will copy this file and paste it here, paste, and let's rename this to dev. This is our config file for the dev environment. Click on the OK, and I will say I will copy this to property, go to this dev properties file. Okay, yeah, it's already there. So let me rename this to Asus, and our laptop price, let's say 70,000. Now we have the two files, and I will come to this properties file, product service. I want to switch to the dev profile. So we have to set the property spring profiles dev. Sorry, profiles dot active equal to dev. So this is very easy to switch between the different environment. We use the profiles string.profiles.active equal to dev. It will fetch the config file from the dev properties. So let me rerun this. Let's go to the postman. Here I will click on the send. Here you see name is Asus, price 70,000. Now we are getting the configuration from the dev environment. If I go here and instead of default I will say dev, click on enter. Now our profile is dev and the property default properties also you can see here. This one is for the default property and this one is our dev properties. Dev config name is Asus, price is 70,000. So this is how we can add a different environment also. And if we have the multiple microservices, if we have the payment microservices, I will create this soon. So we can add that also in our Git repo. So this is the centralized configuration we can create. We can create a Git repo and store all our configuration in one place. Then we'll create a config server. We connect the config server to the Git repo and then we'll add our microservices, talk to the config server when so we can fetch the configuration from the config server. So this is all about the config server. Next we will see how two microservices can communicate to each other. So next we will create a new microservice called a payment microservice. Right now we have the product service and Spring Cloud config server. So inside a payment service we call the product service to fetch the product details. So we will see how two microservices can talk each other. I'm using the Fin framework provided by the Spring Cloud. So before we go ahead, I'm to share the one thing I forget to tell you. But I'm first the Spring Cloud config server. If I go inside this src main Java, resource here application.properties file. Here we are given the path for our Git repo. This path. Make sure that in this path there is a no space, otherwise you will get the error. Make sure that there is a no space. So let's go to our Spring initializer and create a new microservice. Language, I have choose the Java, project Maven, Spring Boot version 3.3.7, group microservices, then artifact ID, I will say payment, service, packaging jar, Java version 21, then dependency I will add, first dependency, web dependency, then dev tool, dev tool. So whenever we make the changes, our server will reload automatically. Then I will add an actuator that help to monitor and manage our application. Then next dependency I will add this declarative REST client. Using this openFeign, we can make the microservices and talk each other. Click on the generate, it will generate a GIF file. I will open that file in my IDE. Now here you can see this payment service has been added. So let's go to this src folder, main, Java. Here I will create a new class. Click on the new Java class. Let's call it payment. Now we'll add a attribute. So private string name of the product. We will fetch this from the product service. Private string price. Then private double quantity. price is not string, this is double. Now next I will add a total. Then next I will add attribute for the code. After that, we'll generate a constructor. Click on generate constructor. First I will add the default constructor. Then I will add the parameterized constructor. Then next I will add the getter and setter method for this name, price, quantity, total, code. Click on OK. Now here we are done. We have the payment class. Next I will create payment controller. Now inside this payment controller class, add a notation, REST controller, and then I will add a notation request mapping and provide a path, let's say payment. Here I will create one post method. So using the annotation post mapping method, it will return the payment object. Let's say get payment details, and we will pass the quantity in our body. So request body payment object, and then we'll return the new payment object. But here this payment object have the name and price, the product details also. So we'll call this product service, this product service we will call. For that I will create another class here, and let's call it payment proxy. Payment proxy. This is not a class. Remember this, I made a mistake here. This one is an interface. This one is an interface. I will repeat. This is not a class. And before that I proceed, I would like to add a annotation here. If you remember, in our form.xml, I will show you, we have added the dependency, the string cloud starter openFeign dependency. So we need to enable that our Feign client. So add a notation, enable Feign clients. Now our Feign client is enabled. I will go back to our payment proxy interface. Then here I will add a Feign client annotation, and we will pass the name of our application which we want to talk. In our case, our name of application is product service. So write our microservices name product service, and it is running on the URL. We need to pass running on the localhost http colon slash localhost 8000. If I show you control shift 1 application.properties file for the product service. Here our product service is running on the port 8000. Okay, so let's go back to our payment service. Here our the port number 8000. Our services product service is running on the 8000. Now then I will add a method. We call the method product get product details, and endpoint is slash product. I will show you first and then we will proceed. So go to the main, here product controller, here endpoint is slash product, and here we have the get method, get product details. It return the name, price and port number as a response. So let's go back to our payment proxy. Here we will add a method get mapping and provide an endpoint product, then public return the payment get product details. So here basically this get product details is the method that we have here. It return the name and get price as a import as a response, and then that response will map with this payment. This is the beauty of Feign client. So we can our microservices can talk each other. Now we are done. We will get the name product details. I will go back to this payment controller here and call this payment proxy. Payment proxy variable we create. Add a notation auto wire. Now using that payment proxy, we call the method get product details. It will return the payment object. This payment object quantity and total. So we have to set. Then let's set this quantity. Set quantity. We will get the quantity from the this payment object from the body. We will pass the quantity. So payment dot get quantity. Then we will set the total. Set total. We will get the total. We will multiply the quantity into price. So payment dot get quantity into pay pay dot get price. Now it will return the total. Now I will return this pay object which type is payment. So here our post method is done. I will return our application. Sorry, in your payment service, and I will return our application. Application.properties file. Let me add a server port also. Server port or application is running on 8002 from working. Now I will go to this postman. Our application is running on 8002. Payment service is running on 8002. Endpoint is slash payment. And this is our post method. In body, we will pass the quantity. And quantity is let's say 2. And click on send. Now here you can see we get a response, select response, price is 7,000, quantity is 2, 7,000 into 2, 14,000 as a total, port is 8,000 because our product service is running on the 8,000. Here we have successfully called the product service from the payment service. Now we have seen how can two microservices can talk to each other. We have the payment service, and inside this payment service we call the product service using the framework Feign client. Now next we will see the naming server and then load balancing. So let's see. First I will explain. Here we have the naming server and multiple microservices. Here we have the product, payment, and suppose XYZ microservices. All those microservices first we register in our naming server. I'm using the Eureka as a naming server. So suppose this product microservice want to talk to the payment microservice. First it will go to the naming server, ask for the address, then the address of active instance of the payment microservice. This is how that product microservice talk to the payment microservice. Also we are using the openFeign framework, so it will do the load balancing also. It will distribute the load among the active instances of microservices. So now I'm using the naming server Eureka. So let's go to this initializer and create a Eureka naming server. First choose the language Java, project Maven. I will choose 3.3.7. Then microservices, then artifact name, let's say naming server, and make it small naming server done. Then we have the web dev tool actuator. Then I will add on one more dependency, which is Eureka discovery client, no, Eureka server. Okay, and then click on the generate. It will generate a naming server zip file. I will open this in our ID. Here I open this naming server. Let's add this naming server to our main project main, and then Spring Boot microservices. We have the folder microservices folder, and here we have the naming server. So click on OK. This has been added naming server. First I will go to the application.properties file, and we will configure our application name is naming server. Then I will set the server port equal to 8761. Then first I will set the properties when the Eureka client register itself. By default it true, so I wanted to make it false. So for that I will set a property Eureka dot client dot register with Eureka equal to false. Go to our naming server application main file with the annotation Spring Boot application. I will add one more annotation, enable Eureka server. I will add this annotation and simply run this application. We'll also add one more property here, Eureka dot client dot fetch registry equal to false. So basically we just make it false. So Eureka client not registered itself in Eureka server, and it's running on the port 8761. Yeah, Tomcat is started on port 8761. So let's go to the browser. Localhost 8761. Here you see our Eureka server has been set up, and currently there is a no instance available. So now our first step is done. We have done with the setup Eureka server. Now second step is we will register our microservices to this Eureka server. We have the microservice, two microservices, payment service and product service. So this is very easy to register microservices. We just have to add a dependency. Let's search for the dependency Eureka client. This dependency, explore, go down Eureka dependency. Yeah, this one dependency I will copy. Come back to our ID in payment service. I will go to your form.xml file, and here I will paste it, reload the main, rerun our application also. Now if I go to the browser and reload, refresh this, here you see the payment service is running on port 8001. Now similar way we'll add the product service also. Product service, go to the form.xml file, simply add one dependency, Eureka client, Spring Cloud Starter, Netflix, Eureka client, reload the maven, refresh. Also, I will set the one properties. First, let me show you this. Now, if I go to the browser, refresh the page. Okay, it's still running. Let me check. Product. Added the dependency. Let me refresh it again. Still, there is only one I can see. Let me change the port. And rerun. And now if I refresh, still I can't see. Form.xml, I will copy the dependency. Now here you see the, I don't know why is it not showing, but now we can see the product service is running on a 8002, maybe 8000 because of the local host port, I don't know, but now it's showing the both the microservices. Payment services running on the 8001 and product service is running on a 8002. Now what I will do, I want a multiple instance of this product service. So I will go back here and I will run the another instance of product service. Go to the edit, add a application, click on plus application, we'll add a new application, we'll say product service, then class path product service, select main class path, then working directory I will choose the product server service, and environment variable we can pass here server dot port equal to, I wanted to run on a port 8003, and okay, click on the run. Now you see our another instance of product service is running. It's running on port 8003. Now I go back here, refresh the page. Now you can see we have the two instances of the product microservice which is running on the port 8003 and 8002. Now we don't need to pass the hard-coded URL. If I go to the our payment service, we have configured this payment proxy. I will just remove, no longer need this hard-coded URL, so I'm removing this hard-coded URL from here, because our application, all our microservices we register in our naming server, and this main client provide a load balancing also. So this payment microservice called the product microservice, and it will check naming server will run with the any active instance of this product microservice. So we don't need that URL. Just by removing the URL, here we implement the load balancing also. Let me rerun our application. Back to our postman here. This is our payment microservices running on 8001. If I show you here, it is running on 8001, and our product is service is running on the 8003 and 8002. Now click on this side. Here we get a response. Here port is 8003. Now if I click on this side, now port is 8002. Now here you can see it take dynamically 8003. Now if I click on the same, it's 8002. We have the two active instance of the product microservice, and it dynamically take any active instance of the product microservice. Now it's still 8003. If I click again, now it's 8002. So this is how we see naming server and load balancing. So next we will see the API gateway. So next is a API gateway. API gateway is like a single entry point for all the microservices. Whenever request from is routed through the API gateway. Suppose product microservices, it want to talk to the payment microservice. First it goes to the API gateway and then it goes to the payment microservice. So it's like a single entry point for all the requests. Whenever we want to implement some common functionalities in every microservices like authentication or any other common functionalities, we can route the request through the API gateway, and then it will be like a single entry point for all the requests. So first we will create a API gateway. So let's go to the Spring. I will remove the change the name. Here we have this artifact naming server. I will write the API gateway. Okay, jar 21. We have the dependencies web, dev tool, actuator, and we need a discovery client also. And then I will add a API gateway, reactive gateway. Click on the generate. It will generate a zip file. I will open this file. Here you can see this API gateway. Let's add this maven API gateway. Select the API gateway. Click on the OK. Now here you see the API gateway service is added to the maven. I will go to this application.properties file to set the port. Here application name is API-gateway server dot port equal to, it's running on 8765. Then I will add a property to set the Eureka server path. Eureka dot client dot service dash URL dot default zone equal to http colon localhost. Our Eureka server is running on the 8761 dash Eureka. Now we are done. So let me run this application. Our application is running. Here we get an error. MVC found a class path which is incompatible with the Spring Cloud Gateway. So let's check the class path. Which class path? Okay. Okay, it's saying that remove the Spring Boot starter web dependency. Yeah, we need to remove that dependency. So let me remove that dependency. Rerun the application. Here we register this API gateway which is running on a port 8765. So all our request goes through this API gateway. And here we register this in our naming server. This service name is payment service and another one is a product service. So I will copy this name payment service, go to our postman and here localhost 65. It is for the API gateway and our service name is payment service and click on the send. Here we see the message 404 not found. That is because we need to set the one properties in our API gateway. So go to the API application.properties file. API gateway, here we need to set a properties spring dot cloud dot gateway dot discovery dot locator dot enabled equal to true. We need to enable this gateway discovery, then only it will find the our service. Now let me go back, click on the send. It's running. Click on the send. Okay, connection loss. Logo. Yeah, it's running on 8765. Let me go back and click on the send. It failed to resolve the Kirti queries. So here we are getting the error 500 internal server error, failed to resolve the kirti.ms home.net, unable to resolve the DNS resolver context. Okay, if you see here, if you go to the browser and here this is the kirti.ms home, this DNS domain name is not resolved. So what I will do, I will go to our naming server properties file, go to the naming server properties file, and here I will add a localhost and IP address. So Eureka dot instance dot host name. I will add a host name localhost and machine IP address Eureka dot instance dot IP address equal to 192.168.0. So you can add your machine IP address here. Now let's add these two things, host name and IP address, to our payment service also. So I will go to the payment service properties file, resources, application web properties. Here I will paste it, host name and IP address, and rerun our application payment service rerun. Now here we can see we get the result, name Asus, price, quantity, total, and we use the payment service as a name here. Our API gateway running on port number 8765, and then our service name payment service and payment. If you check this now, if I go to the browser and show you, this is our product service. I will copy this product service, come to the postman. Here I will rename this to this product service, control P, and payment I will say product endpoint and click on the same. Okay, product say no static product 404 error. So let me copy that local host name and IP address. Copy. Go to the product service src main resource application.properties file. Here I will paste it and rerun our product service application. Wait for a while. Product service application listen. Also I will rerun. Let me change the method name and click on the send. Now here we get the name, price and port. Okay, and try again, click on the send. Now port is 8002. Then again click on the send. Now port is 8003. So it dynamically get any active instance of the product service. Code in this product service name is capital. We will set a property in our API gateway. So let's go to the API gateway. Target src resource and then here application got properties. Here I will set the I will copy this one. Copy locator rover case service ID true. Now rerun our application this API gateway. Stop and rerun. Now I go back, click on save. Where we get 404 not found error. So in small letter I will type product service product dash service and click on the send. Now here you see we get a response. So we have seen the API gateway also. So in this video we have seen first we start with the centralized configuration using the Spring Cloud config server. Then we set up the our config server. Then we see how we can talk connect with the Git repo and we created different profiles and fetch the config from the config server. Then we have seen the openFeign framework. So two microservices can communicate to each other. We see how the payment microservice called the product microservice, and then we see the load balancing. Then Eureka server, naming server we see, and then in the last we see the API gateway. All the requests route through the API gateway. So I have covered all these things. If you like this video, then don't forget to like, share and subscribe to Imaginary Engineering. Thank you for watching.